Hello students. Now remember we are still looking at similar figures, and for now let us have example 1. Identify similar triangles and explain your answer. So we begin with number 1. We have two triangles ABC and PQR. We don't know if these two triangles are similar, but we note that two triangles are similar if the corresponding angles are equal, or the ratios of corresponding sides are equal. Now for this case, we only have angles. We do not have the sides. So we are going to follow the principle that two triangles are similar if the corresponding angles are equal. Now, we need first know which angle is this and which angle is this. Remember, the sum of interior angles of a triangle is 180 degrees. So, let us find angle CAB. So, angle CAB will be 180 degrees minus 70 degrees minus 49 degrees. And this will give us 61 degrees. So this means that we have 61 degrees here. Let us find angle QRP. QRP. So this will be 180 degrees minus 61 degrees minus 70 degrees. And this will give us 49 degrees. Okay? Therefore, we note that angle CAB, this one, is equal to angle RPQ. RPQ, this one. And so it is equal to 61 degrees. Okay? We can also see that angle ABC is equal to angle PQR. Angle ABC, this one, is equal to angle PQR, this one. So, and it is equal to 70 degrees. We also see that angle BCA is equal to angle QRP, BCA, this one, is equal to angle QRP, this one. Remember, here we have 49 degrees. So, angle BCA equals angle QRP and equals 49 degrees. Now, you can note that all the corresponding angles are equal. You see that? Since all the corresponding angles are equal, then triangle ABC is similar to triangle PQR. Okay? So the two triangles are similar. Okay, so let us have another example. This is example 2. And you can see that in example 2, we do not have angles, but instead we only have sides. We also know that two triangles are similar if the ratios of the corresponding sides are equal. Now we will take a look at the ratios. Ratios of corresponding sides. If we discover that the ratios of corresponding sides are equal, then these triangles will be similar. So we see that side ST is the longest. So if these two triangles are similar, then side ST must be corresponding with side DE, because these are the longest sides. Then the second longest, which is TU, must be corresponding with EF. This is because TU and EF are the second longest. Then the shortest, which is SU, must correspond with DF, which is also the shortest. So this means that we say side ST out of DE is equal to ST is 12 and DE is 8. And this will give us 1.5. We go to the second longest, which is TU out of EF. So this will be TU, which is 9, EF, which is 6. And this also will give us 1.5. Then lastly, we get the shortest one, which is SU out of DF. SU is 7 and DF is 4. This will give us 1.75. You see? Now that you can see that the ratios of the corresponding sides are not, you see, this ratio is 1.5, this one is 1.5, but this is 1.75. So I don't think that these two triangles are similar. You see, since the ratios of the corresponding sides are not equal, then triangle DEF is not similar to triangle STU. They are not similar. This is because the ratios of the corresponding sides are not equal. So, you will go on page 93 and do this practice question. When you finish it, you go and do exercise 3A, question number 2. This is the same as example number 1. Now let us look at example number 2. Given that triangle ABC is similar to triangle PQR, find the values of the unknowns. Okay? Now, for this question, we see that these two triangles are similar. Now, since they are similar, it implies that the corresponding angles are equal. It also means that the ratios of corresponding sides are equal. Now, for that case, we need to know the values of unknowns. So, step 1, we need to know which sides are corresponding and which angles are corresponding. You can see that AC is the longest side of triangle ABC and RP is the longest side of triangle PQR. So this means that AC corresponds with PR. Then AB is the second longest and QP is the second longest. So AB corresponds with QP, and of course BC corresponds with QR. That's what it means. So, and also we see that this is the biggest angle ABC. So ABC corresponds with PQR. So these two angles are equal. Then you see that BAC is the smallest angle. So this one will correspond with this one. And then, of course, this angle corresponds with this angle. And for that case, it means that X equals 25 degrees because these are corresponding angles. Okay? Now we need to know the value of y. We will know value of y using the ratios of corresponding sides. So we say that BC corresponds with QR. Okay? And then remember the ratios of corresponding sides are equal. So we say that BC out of QR is equal to AB. Remember AB corresponds with PQ. We are using equal signs because we already know that these two triangles are similar. Okay? And if they are similar, the ratios of corresponding sides are always equal. So BC is y, QR is 3.2. This is equal to AB, which is 7.5, out of PQ, which is 5. So we will cross multiply. So we get 5y equals 7.5 times 3.2, and y equals 7.5 times 3.2 divided by 5, and this is equal to 4.8. So therefore it means that x equals 25 degrees and y equals 4.8 centimeters. So you go to page 95, you do this question for practice, and when you finish, you go to exercise 3A and you do question number 1, number 3, up to number 5. These questions are similar to example number 2. Let us look at example number 3. So, given that triangle XYZ is similar to triangle XPQ, find the values of the unknowns. So we need to know what is A and we need to know what is B. So actually here we have two triangles. Okay? We actually have two triangles. One is X, Y, Z, and this is 70 degrees. Here we have 2 centimeters and here we have 3 centimeters. Another triangle is PQX, whereby this is A, okay, and this is B. This is actually B plus 3 centimeters, the whole of this one. And then PX is 2 plus 4, which is 6 centimeters. Okay? Now, we need to know A and we need to know B. So we can see that XYZ angle XYZ corresponds with angle XPQ. So it is equal to angle XPQ. XYZ is equal to angle XPQ. So this means that since XYZ is 70 degrees, then XPQ is A. It therefore means that A equals 70 degrees. Okay? Then we can say that also XQ corresponds with XZ. And since these two triangles are similar, so it implies that the ratios of corresponding sides are equal. So that's why we use equal sign. So XQ out of XZ equals XP out of XY, because XP corresponds with XY. So we know that XQ is 3 plus B, which is the same as B plus 3. And then XZ is 3. And it is equal to XP, which is 6, out of XY, which is 2. Okay? So when we cross multiply, we will get 2 into 3 plus B, which is equal to 3 times 6, which is 18. So 2 times 3 is 6, 2 times B is 2B equals 18. So 2B equals 18 minus 6. So 2B equals 12. And B equals 12 divided by 2, which is equal to 6. So therefore B equals 6. So it implies that A is 70 degrees and B is 6 centimeters. Okay? I hope that you have understood this very well. Now, you go to page 97 and you do practice now. Okay? And when you finish that, you go to exercise 3A. You answer questions 6 to 9. These questions are the same as example number 3. Thank you so much. We meet next time. Goodbye.